Chapter 2, Lesson 1, Part 1, Scientific Notation. Vocabulary. Scientific notation is an abbreviated form of a number that contains a coefficient equal to or greater than 1 and less than 10, multiplied by a power of 10. For example, 7.2 times 10 to the third power. Coefficient is the number being multiplied by the power of 10. So 7.2 in our example. And then standard form is a number just in its regular form. So understanding scientific notation. Again, a number in scientific notation is a coefficient greater or equal to 1 and less than 10. And then it's multiplied by a power of 10. So here we have some examples. 53 times 10 to the negative 2 power. This is not in scientific notation because 53 is greater than 10. Letter B here, 1.5 times 10 squared. Yes, this is. 1.5 is greater than 1 but less than 10. And then we have 10 to the second power. So number 7, 2.1 times 10 to the fourth power. 2.1, that's greater than 1 and less than 10, multiplied by 10 to the fourth power. So yes. Number 8, 90 times 10 to the negative second power. 90 is greater than 1, but it is not less than 10. So no, this is not the coefficient. Is not less than 10. Okay. Number 9, 0.01 or 1/100th times 10 to the negative third. Again, this is a no. The coefficient is smaller than 1 here. Okay. And lastly, number 10, 7.8 times 10 to the third power. 7.8 is greater than 1, but less than 10, times 10 to the third power. Yes, this is in scientific notation. So writing numbers in scientific notation. So remember, for a number to be in scientific notation, the number must be greater than or equal to 1 and less than 10. And then you're multiplying by a power of 10, where the exponent is an integer. Again, an integer is the negative and positive counting numbers. So, an example here we have letter A, 1,352. We can write 1,352 in scientific notation simply by dropping in a decimal here. We're going to put in the decimal so that there's only a digit in the ones place, nothing higher, and then everything else is after the decimal. And then 1.352 times 1,000 is equal to 1,352. If you notice, if the decimal was here in our original number, I moved it 1, 2, 3 places to the to the left. So that means 1.352 times 10 to the third power. I'm counting how many places I'm moving my decimal, and that'll tell me what I'm multiplying by. Times 1 with 3 zeros, 1,000, or again, 1.352 times 10 to the third power. So what happens here if we have a number less than 1? We already have a decimal here. In this case, we need to move it to the right 1, 2 places so that I have a digit in the ones place and everything else would be after it. And I moved it 2 places to the right, so that would be a negative 2 as my exponent, because 2 times 1/100th here would be our original of 0.02. So if the original decimal gets moved moves left, I have a positive exponent. Okay, if my original decimal moves right, I get a negative exponent. So let's do a practice one here. I have 769.7. I need to make this into scientific notation, so I'm going to move my decimal so that I only have a digit in the ones place and that everything else is in the decimal places. So I'm moving it 1, 2 spaces to the left. So that would be 7.697 times 100. I get 100 by just putting the 1 and adding how many zeros I move my decimal. So I move my decimal 2 spaces to the left. So 1, 2 makes it 100. So again, I move the decimal 2 places to the left, which told me to multiply by 100. So this stays 7.697, and 100 in exponential form is 10 squared. Again, there's 2 zeros here, 1, 2, so 10 squared. Or again, I move my decimal 1, 2 spaces, so that's where I get the exponent of 2. This is something, the more practice you do, the easier it's going to become. So 978 here. Here's where my original decimal would be at the end. So to get it so that I only have a digit in the ones place, I'd move 1, 2 to the left. So 9.78 times 100, again, because I'm moving 2 to the left, which is the same as saying 9.78 times 10 squared. 2 to the left tells me my exponent is 2, and it's positive because I'm going left. Number 13, I already have a decimal here. So I'm going to move it 1, 2 to the left again. So that becomes 4.566 times 100 because I moved it 2 spaces, or 4.566 times 10 squared. Let's try number 14 here, 0.188. I'm moving this decimal 1 space to the right. So because I'm moving it to the right, it actually becomes 1.88 times 1 over 10, or 1.88 times 10 to the negative 1. Again, because I move my decimal to the right, my exponent is negative. So number 15, 1, 2, 3 spaces to the right. So 4.4 times 1 over 1,000, 3 spaces to the right, 3 zeros, or 4.4 times 10 to the negative third power. So now in this next part, I'm converting actually from scientific notation to standard form. I'm doing the opposite, or simply just doing the multiplication. So letter A here, I have 9.9 times 10 squared. 10 squared is the same as 100. So I would do 9.9 times 100. They made a mistake here, not 99 times 100. It would be 990. And 9.9 times 10 squared would be 990. Because we have a 2 as the decimal, so I'm just moving it 1, 2 spaces, and I'd fill in my 0. Okay, sorry for that mistake there. Letter B, we have 1.07 times 10 to the negative third. As you probably guessed, because it's a negative exponent, we're going to move my decimal the opposite way. So I'd have 1.07. It's a negative 3, so I'm going to go 1, 2, 3 spaces and place my decimal here. Fill in those empty spots with zeros. I get 0.00107. And again, there was negative 3 zeros. So this is just moving the opposite way to get it into standard form. So let's do some practice here. We have 2 times 10 to the third. So we're going to keep it as 2 times 10 to the third. 10 to the third is the same as 1,000, a 1 with 3 zeros after it. And 2 times 1,000, of course, is 2,000. And they would ask you to just fill that in, multiply by 1,000. If I wanted to do it by just moving the decimal, I would have 2 with the decimal here. Since my exponent was 3, I'd move my decimal 3 spaces to the right. 1, 2, 3. And just fill in my zeros. All right, 4.1 times 10 to the negative 2. So it's going to stay at 4.1. This is a negative 2, so it's 1 over 100. I know it's 100 because that has 2 zeros, the same as my exponent, a 2. And that would simply be 0.041. So I'm dividing by 100. Again, if I want to do it with just moving my decimal, which might be easier for you, I start here. And because I have a negative exponent, I'm going 1, 2 left, and I fill in my blank with a 0. And having a 0 in the ones place is good, just good practice. So number 18, 6.31 times 10 to the negative 1. I'm just going to do this by moving the decimal. I think you might find that easier. So because it's a negative 1 means I'm going to move my decimal to the left. So I just bring my decimal over here, and my answer would be 0.631. 1.2 times 10 to the 4th. I have a positive 4, so I'm moving my decimal to the right. I'm going to rewrite this 1.2, 1, 2, 3, 4. I'll fill in my zeros where I have this missing spot. So that equals 12,000. Okay, 9.09 times 10 to the negative 3rd. Again, negative 3, so I'm moving my decimal to the right. I'm going to rewrite it so you can see my movement. Negative 3, I move it 1, 2, 3 spaces. And now I'll fill in with zeros. So that equals 0.00909. Then lastly, 8 times 10 to the 3rd. 8 is the same as 8.0. So it's a positive 3, so I'm going to the right. 1, 2, 3. I'll fill in my blanks, and that equals 8,000.